Okay. So pick up with these notes. When we talk about the homework questions in a little bit, if any of those were creating an issue for you, hopefully maybe some of the things that we see today, some practice examples we do, can maybe alleviate some of the issues on that. Just feedback from first period, the Schoology, when you do that assignment, it's not like the other online stuff because they're static questions and they're essentially true or false questions, like matching population or sample. That's one or the other, right? So if it were to be wrong and I give you multiple chances to do that, even some of us in here would get that right. Right? Right? Lucas? Playing with your hair? Okay, so no, I'm just teasing. So those are static questions, so there's no like multiple chances, similar exercises, that sort of thing on those. And that's pretty much the way Schoology is going to be. If there's an assessment in there, they're going to be one shot and graded right then, right or wrong. So the My Open Math is got some that are, you can do similar, like try a similar exercise or something like that. But that doesn't give you any feedback, and you guys are used to some feedback. So what I'm going to do, I do have some Math Excel codes that I'm going to give you guys. Not today. We didn't get through it first period. But we're going to sign up for Math Excel as well. And we'll use all three. And I know that you might be thinking, now I'm going to have to jockey around homework assignments from 3 different places. I will make sure that you know where the homework is for that day. Sent an email out yesterday explaining to everybody, because we're seeing people leave the classroom, going online. We're seeing people that are online coming to the classroom, and we're seeing people getting quarantined, right? So that is a logistical nightmare for teachers trying to organize Schoology, grade books, content, all that kind of stuff. So what I'm going to do every day at 3 o'clock is I'm going to send you an email just so everybody's on the same page. So when kids come back in 2 weeks and say, well, I didn't know that was there, I didn't know we did that, I didn't see that in Schoology, that kind of thing, I'm going to tell you a brief description, be a sentence long, about what we did in class, what is assigned that day, and probably when it's going to be due. Is that okay? So if you are a person that ends up having to leave or whatever, you can guarantee that email will be about 3 o'clock every day, explaining what we did, so you don't miss anything. Okay. Questions on that? So I think getting you into Math Excel is going to be nice because it gives feedback. It's going to give us access to about 3,000 more questions. Not that we're going to do all of them, but I think the more we can do, the better. In the past, when I taught stats in what year would that be? Like 2009, 2010, 2011, I was teaching stats. I used like 6 textbooks. So I would just pull questions from all those textbooks. And, if we're doing samples and populations like we were doing in that Schoology assessment, I would have gathered 6 sections out of other textbooks and just listed all of those multiple questions about populations and samples, and we would talk through those. Does that make sense? So it's nothing really new that I haven't done in the past. It's just the way it's presented to you and now in a different format online. I think it's going to be a benefit to you. So it might worry you, but I think we're going to be okay. But before we talk about the My Open Math stuff, that some of those questions in there, we're talking about what variables and what things were data. Okay. So I want to talk about these vocabulary words, and then we can target some of those questions. But a variable is, we're going to view it kind of like what we did in like algebra. Variables are things that change, but we don't necessarily treat it exactly like a variable. Okay, we don't treat it algebraically maybe the same way. The one thing that we're going to find out as we move through this course, if you are a person that is developing a research study, okay, do you want to do an experiment? We want to look at different variables that may have impacts on what is actually being sought out in that study. So if I want to test the effectiveness of like a weight loss drug, then I'm going to, one of my variables is going to be weight of my patients. One of my variables is going to be maybe total weight loss of my patients. But there are other variables that are at play, and we'll talk about these in greater detail in other sections, but they're called confounding variables. Okay, there are things that are happening in that person's life, in their personal situation, that might be cause for weight loss. Okay, so let's say that I am a person in this study, but I am also maybe I've got underlying health conditions. Those could be variables that could be the cause of weight loss. Does that make sense? My gender, it could be a variable that would be cause for weight loss, okay, or explain varying weight losses. Does that make sense to everybody? Okay. If you're dieting, okay, that would be a variable that we call those confounding variables. They could mess with what we are trying to study, okay, the effectiveness of the drug. So when we are actually the researcher, we are going to try our best to mitigate and isolate one particular, mitigate all these confounding variables, but isolate a particular variable that we're trying to study, okay? But it says a variable which we're going to note or denote with a capital letter, usually X or Y. It's a characteristic of interest for each person or thing in a population. Okay, so if I was interested in let's say this classroom is a population. If I'm interested in your guys' height, okay, your height is going to be a variable, okay? And, you know, person one's height is going to be different than person two, which is going to be different than person three, which is going to be different than person four, right? So what we say is because those individual values are going to be different, they are varying, right? They change, okay? So they're variable. So the variable can be any characteristic. It can be a number. It can be a quantity that can be measured or counted, okay? So if we talk about your eye color, okay, eye color cannot be quantified, right? Okay. So it's a variable, okay? Your eye color changes from one person's might be blue, next person's might be green, next person's might be brown, okay? But it changes from person to person, okay? The variable, okay, can sometimes be called a data item. Okay, I don't use that term very much, but if you ever come across a reading or something like that, or a video that talks about data item, it's the same thing as a variable. Here it says age, sex, business income, and expenses, country of birth, capital expenditure, class grades, eye color, and vehicle types are all simple examples of variables. Okay, some of those you can quantify, some of them you can't. Some of them are numerical, like age. Some of them are not. Some are what we call categorical. Okay, if it's categorical, it's like male, female. Okay, I mean one of those categories. Okay, if it's eye color, I may be in the blue eye color, green eye color, brown eye color. I'm in those categories. Okay, you've all taken like surveys in the past, especially if you've taken like previous college classes. They'll send you an email about like your experience, okay? And it'll be like, I strongly agree, I agree, I somewhat agree, I'm neutral, I disagree, or strongly disagree with whatever the question was. You've seen those before, right? Okay. It's called a Likert test, okay? Now, those are numbers, okay? So I can quantify like strongly agree a 5, but strongly disagree might be a 0. I can quantify them with a number, but those numbers don't really mean anything. Okay, does that make sense? When we can do that with eye color, I can place blue with 0. I can place green with 1 and brown with 2. Okay, and let you record and collect the data that way. But they're categorical. They don't mean anything quantity-wise. Does that kind of make sense? Okay, so that's what we're talking about, a variable. So it's called a variable because the value may vary between data units in a population and may change in value over time. So your height, your weight, those things individually are going to change over time. but also compared to the people in the population or the sample, they are varying as well. Something that we didn't talk about a little bit yesterday, or we should have talked about a little bit yesterday, is when we talk about a sample. So we're going back up here to this picture here. When we talked about taking those people that I circled in the population and pulling them out in a sample and then running our survey with those people in that sample and determining maybe let's say their average weight, okay? That average weight of that sample, we're going to use it to help us understand the average weight of the population. We talked about that yesterday, right? Okay. Now, what we like to do is we like to put those people back in the population and pick another random sample. So when I do this a second time, I get another random sample. I want to have different participants, okay? I could, because it's random, have some repeat participants. That does happen, okay? But when I find the average weight of that second sample, that average rate, that statistic might not, I'm going to say might not, it will not be the same as the average weight in the first sample. Does that make sense? Okay, so if we took this classroom and I took these three people and did their average weight, okay, and I said that was a big enough sample to actually allow that number to represent the population. But then I did the sample again, but I used these three people, okay? This average of these three people is going to be different than this average of three people, right? But they're going to be in the ballpark of one another. Does that make sense? Okay. So those are called, we'll talk about those as sample distributions later on. But you might see a question in the next couple of days that says something to the effect, if I take a sample a first time and figure out the statistic, and then I take a sample a second time and figure out the statistic, do those statistics of those two samples have to be the same? And they're not going to be, okay? But they should be close. Does that make sense? Okay. And what we'll do, like a good study is, okay, we'll take these three, we'll do a sample once, do a sample twice, do a sample 3 times, 4 times, 5 times, and now we've got basically taken all those samples, we now have a cluster of sample averages that we can actually use that information better together collectively to represent the population than just the one sample mean. Does that make sense? Okay. You guys ever seen, like you ever been in we did a couple years ago now. You guys remember that Yes Fest stuff that we did a couple years ago? Yeah. Somebody had like a jar of M&Ms and said, guess how many are in here. And if you guess it right, you'll get that jar of M&Ms. Okay. You've probably done been in other situations like that where you're guessing on how many things are there. And some people are just crazy to say, well, there's 5 there and it's a full jar. And some people say, well, there's 100,000 in there. Okay, just ridiculous answers, right? Okay, but collectively, okay, if we have like 300 people make guesses, and I'm the 301st person to guess, I'm going to take the average of those 300 people that guessed before me, and that's going to be my guess. And I'm going to win that M&M jar every single time, because the collective guess of everybody statistically is better than me guessing on my own. Does that kind of make sense? Okay, and that's kind of almost parallels the idea of taking a bunch of sample means and putting them in a cluster and using them to then model the population. When we look at this, it says, for example, income is a variable that can vary between data units in a population. It says the people or businesses being studied may not have the same incomes and can also vary over time for each data unit. A lot of studies are done to judge the income levels of like first-year graduates, okay, first-year college graduates, okay, and depending on your degree is going to depend on your income or your income, I guess, is going to depend on your degree. So you might be an engineer and make $90,000 a year. You might be a social worker and make $25,000 a year. It just, depending on those variables of what your degree is, can then change the variable that we're trying to study of your income level. Does that make sense? Okay. It says variables may be numerical or categorical. We kind of already talked about that. Categorical, a lot of times when we collect that data, it is then somewhat difficult to actually do calculations with that data, but we'll investigate some categorical variables throughout the course. Categorical variables place a person or thing into a category, like we said, eye color or socioeconomic class, something like that. If we let X equal the number of points earned by one math student at the end of a term, then X is a numerical variable, okay? So age, grade point, those types of things, income level, those are quantities, so they're numerical. It says if we let Y be a person's party affiliation, okay, so if you're Republican, Democrat, Independent, those are categorical, right? There's no number attached to those, so a lot of the calculation stuff might be difficult there, but like I said, we'll experience that stuff later on. So data are the, or data, however you want to say it, are the actual values of the variables, okay? So depending on what type of variable you have, the data might be numerical or it might be one of the categories, okay? So that's what it says. They may be numbers or they may be words. You're not going to hear me say this word a lot, but datum is a single value, okay? I like when I refer to a single value of data, I refer to it as a data point, okay? But we can say datum if we want to. So if I'm talking about eye color, blue, okay, would be student A's eye color is, what color is your eyes? They're green, okay? So green for him is a datum. Does that make sense? Okay, it's one of the categories, but I'm looking at an individual result, so we call that data. All right. Your height. If I'm doing weight or height of everybody in this room, okay, each individual weight or height is a datum. Okay, you win everything. Shiny hair goes to somebody else. So if we read this example here that we've already talked about, we decided the other day that we're talking about our population being all first-year students at this college. We said our sample was the 100 that they were going to survey. We said that the parameter was the amount of money, the average amount of money spent by first-year college students. And remember that then the parameter has to be the same thing, the same measure that the statistic has to be. So if I'm measuring money spent by first-year college students, and that's my parameter, then money spent by my people in my sample has to be my statistic. Does that make sense? Okay, money spent, if that's my parameter, my statistic can't be average age. Okay, those things don't match. Okay, so we figured that stuff out the other day. But as we go through this, it says 3 of those students spent $150, $200, and $225 respectively. Okay, so when we want to talk about the variable is the thing that we are measuring, but it's the thing that is changing from person to person or situation to situation. So would you guys agree that the amount of money spent is what is varying? Well, that's my variable. Okay, and that's going to be these first-year students. Okay, now we have specific situations where one student spent $150, one spent $200, one spent $225. Those individual values are referred to as the data. Does that make sense? Sometimes I think it's easier maybe to realize what is the data, and that might help you recognize what the variable is. Okay, they should relate to one another. Okay, you guys have any questions over that? Does that make sense? If we start talking about something, guys, and it gets confusing, doesn't make sense, stop me, and we'll move on. Okay. Sometimes I'll post like little footnotes. We talk about means and averages. Okay, they're analogous here. Okay, the term that we use for most times is mean. Average is usually referred to as the arithmetic mean. Okay, but we interchange those words, and they're going to have the same meaning to us. Okay, so we got some examples of population versus sample. These are similar to what you saw in Schoology if you've done that yet. Remember that to do this evening. I'm sorry, tomorrow evening. First one says a factory overseer selects 40 threaded rods at random from those produced that week at the factory. She then tests their tensile strength. Okay. First of all, what's tensile strength? You don't know? Your dad being who your dad is, you don't know what tensile strength means.
I don't even know what tensile is.
Probably the easiest way to think about tensile strength is if I take my shoestring and I start pulling it, at some point that shoestring is going to do what? Break, right? And the amount of force that it took to break that is the tensile strength. That make sense? Rope has a tensile strength. You go to Home Depot or whatever, and rope will say like 100-pound strength or whatever. Or fishing line has a test on it. They call it like 15-pound test, 20-pound test, 10-pound test. Basically, that's the tensile strength of that.
Rope have like thousands of pounds.
Huh?
Rope have like thousands.
Some do. Some don't. Like you go to a dollar store and you buy some rope. It's not very good.
Well, that's different though. Like
How's that different?
It's like thin rope.
What's what?
Thin rope.
Thin rope. A lot of that rope is actually the core. The core of that rope is just paper. Do you know that?
Real rope.
Huh?
Like real big rope.
Okay.
It's got to be like thousands of pounds.
It is. Yeah, like that rope you like swing in the weight room. Yeah. Good talk. All right. When they're doing this, okay. So what is the sample? I think that might be in this question the easiest thing to look at. What are we sampling? What group became the sample? What's the smaller group up there? The 40 rods. Okay, the 40 rods chosen that week. So that means the population had to be all rods that were made that week. Does that make sense? Okay. If you go buy like a brand new pair of shoes, before the first time you look at them, or I guess wear them, look at the inside of them. Somewhere there'll be a sticker that says something like Q.C. and then it'll like have a number on it, or it might have initials on it. It's quality control. Okay. That means those shoes were looked at, they were investigated by somebody to make sure that they were like the other shoes that they were making. Does that make sense? Okay. So when I go to Foot Locker and I have a choice of picking this box here or that box there, it shouldn't matter which one I choose, right? Does that make sense? Okay. Because they are made the same way. When I go to Meijer and I want to buy Tide Pods or just Tide in general, the liquid form, I don't want to have to go and like feel the weight of those Tide Pod containers to see which one has more in it, which one has less in it, right? I should be guaranteed that the one in front, if it has 30 Tide Pods in it, the next one has 30 Tide Pods in it, right? Okay. And what they do at P&G is that they will take off the assembly line a finished product, and they will go through and they'll count. Is there 30 in this one? Okay. And then they'll go, 20 production items later, so the 20th bag after that, or whatever they've decided is sufficient to count another grouping, and they'll make sure there's 30 in that bag. And they'll go to the 20th one after that and make sure there's 30 in that one. Does that kind of make sense? And what they can do is they can start to see, okay, if we're doing that and we're not seeing any change in this 30 to this next 30 to this next 30, then our system is operating correctly, right? Okay. They do the same thing with weights of, liquid that they put into the detergent bottle. Okay. So I have to go to Meijer's and weigh each one to know which one I need to buy. But when they do that quality control, they're essentially doing a sample of everything. They don't check every one. If they check every one of them that they make, they are being inefficient with their resources, right? But if they can check all of them, or every like 20th or 30th or 40th, they're going to be able to judge the population a little bit better and a little bit more efficient. Okay, so that's called systematic random sampling, and we'll get into the details of how that's done, but that's what's going on in this situation. Okay, you ever been to, anybody done like plumbing or anything like that? You've done some plumbing? Okay, so I think we all understand the idea of plumbing, right? Like when I go to the store, there's straight pieces of PVC. Let's use PVC for plumbing. You can use copper, whatever you want to use. But let's say I've got straight pieces of PVC, and there are then connections that like allow it to bend. They're called elbows, that kind of stuff, right? You got Ys that go off in different directions. But I should be able to go take a half-inch piece of PVC that is in a straight section in one store. Maybe I do this at Menards. And then I'm going to go over to Lowe's, and I'm going to go find 1/2 inch like elbows that go with my 1/2 inch pipe. Okay, so elbows are going to make it turn. Okay, and I do that at Lowe's, and I buy those. And then I should be able to go to Home Depot, and I can get Ys. So a Y is something that like branches off in two directions. Does that make sense? It looks like a Y when you're done. And I should be able to go get those all 1/2 inch from 3 different stores, and they should all fit together snugly. Does that make sense? Okay. And now you have to put like PVC glue on them and everything, melts the PVC so that it is not going to, with under pressure, like fly apart. But when they're manufacturing those things, they are checking the tolerance of those 1/2 inch measurements to make sure that you should be able to go from store to store or bin to bin and choose any 2 1/2 pieces, and they should fit together snugly so that you can do your plumbing. Does that make sense? Okay. So what they'll do is they'll do quality control. They'll do systematic random sampling on the assembly line to make sure that those things are happening. The tolerances of those dimensions are not out of whack, so that you get home and you put everything together and turn your water on and you got a mess. Does that make sense? Okay. Second one says the State Department of Transportation wants to know out-of-state vehicles that pass over a toll bridge with several lanes. Camera installed over one lane of the bridge photographs the license plates of every 10th vehicle that passes through that lane. Okay. When it says every 10th or something like that, or every 40th, or selects a total amount of 40 from a larger group, or 10 from a large group, something like that, it's identifying your sample. Does that make sense? Okay, so every 10th, when we do that, that is going to generate our sample. Okay, what's the population in that scenario? Yeah, all out-of-state vehicles. Okay, and it's going to be in this situation because we're narrowing our focus. It's all out-of-state vehicles that passed over that bridge, right? Okay. What about C? It says a pediatrician randomly selected 10 parents of his patients. Then he surveyed the parents about their opinions of different kinds of diapers. So pediatrician is doctor for kids, right? Okay. So what is my sample there? My 10 people, right? My 10 parents. Okay. What is the population that they came from? All parents of his patients, right? Okay. Looking at that, what would so diapers could be Huggies, could be Pampers, maybe they like the cloth ones.
The jean diapers.
Huh?
The denim ones.
Denim jean diapers? Like that's a thing?
Yeah, they're bad.
I bet that would be uncomfortable. Okay, so we got these diapers, and so those are the type of diaper would be the variable. Does that make sense? Now, is that numerical or is type of diaper categorical? Categorical, because it's got a name to it, right? Huggies or Pampers or denim jean. I've never heard that. I think you made that up. Just because you wear jeans and you need a diaper but don't wear a diaper doesn't turn your jeans into a diaper. Okay. All right. Administrators at Riverview High School surveyed a random sample of 100 of their seniors to see how seniors at the school felt about lunch offerings. Okay. This is, in a situation like this, they probably did one of those, like I said, a Likert scale. With you agree with it, or you like it, you dislike it, you strongly dislike it, that kind of thing. Okay. Sample. I mean, these are pretty simple when they say they took a random sample of 100 of their seniors, right? That automatically identifies their sample for you. What's the population that they came from? All their seniors. Now, with situations like this, we want to make sure that we are specific and we don't just say all seniors. And I think And we talked about this in the first period today. Somebody said, it's just all seniors. So I'm like, so you're a senior. Does this mean you? So what we want to do is we want to make sure we specify all seniors at Riverview High School. Does that make sense? Okay. Because we want to make sure that if our survey is specific, that our analysis of it is specific as well. So we don't want to make a argument about something, and then somebody that's reading that research misconstrue what my findings and apply it to something that it shouldn't be applied to. Okay. E says an insurance company would like to determine the proportion of medical doctors who have been involved in one or more malpractice lawsuits. The company selects 500 doctors at random. So right there, that's when it tells you how they're selecting or how they're choosing people or whatever. That tells you your sample, right? So we select 500 doctors. There's my sample. But what did that sample come out of? The population is all medical doctors, right? Say again? I can't hear you. No. Because basically what they're going to do is they're going to say, if we said all medical doctors who have been involved in one or more, well, I guess I didn't read that. No, because if my population was all medical doctors who have been in one or more malpractice lawsuits, and then I selected 500, my sample and my population would really be the same thing. Does that make sense? My 500 would automatically all been in one or more. Does that make sense? So in that 500, I want some of my doctors are not in malpractice lawsuits. That's a good question, and so I think that's kind of hard to think about. That the answer to that question or to explain is sometimes difficult to do. So there, the variable could be, and these are things that we have talked about, where there could be some leeway in some of these studies. And as the head researcher in the study, you would discuss this, talk about this, you would report on this. One of my variables could be 1 malpractice lawsuit, 2 malpractice lawsuits, 3 malpractice lawsuits. So it could be how many different lawsuits I've been in. Does that make sense? Okay. And it could be maybe a yes or no. Okay. Have you been in 1 or more lawsuits? Yes. Not then quantifying whether there's been 2 or 3 or 4 or 5. It's just, yeah, I've been in at least 1, right? Or no, I haven't been in any at all. Okay. So as a researcher, you would want to determine how are we going to essentially deal with these variables. Okay. But that's all stuff that we'll talk about and discuss more specifically in other chapters. Is that all right? That kind of makes sense? Okay. When you guys were in My Open Math, there was a question that some guy that was talking about like voter or people went to vote somewhere, and then it asked you like A, B, C, D, E, and F on identify the population, identify the sample, identify the individual data values. Just know, like, that question might be confusing because the way it's worded. When we're in a test or quiz scenario, and this is another reason why I'm going to give you Math Excel, because just looking through some of the things I've seen in Math Excel, the questions are worded a little bit better than what that was in My Open Math. I'm going to be clear with you. I'm not going to leave it up to your judgment on whether is that a data point or is that a variable or whatever. Does that kind of make sense? So one of the scenarios was talking about people that voted, and it said voted, like just option E was voted, not voted, voted. Okay? And that was confusing for people. Was that the variable or is that the data? And basically what that was doing is it was showing me I had 3 people, and the vote meant, when it said voted, that was the data value for that person. So it was a data value. Okay? Not voted is another data value. Voted is another data value. Then the variable would have been whether they voted or not out in words. Does that kind of make sense? And that's kind of I think it's just a poor wording, I think, on their part. And that's the thing with my open math. It's the thing with all the online homeworks that I'm going to give you. They're pulling from a pool of questions. And I see the initial one. And I see the initial one that I want to assign to everybody. And I really like it. And it assigns it to 2/3 of you, but the other third might get the one that's behind it that might not be as well written. Does that make sense? And those types of things, if you come across questions like that that is really confusing to you, let me know. We work it out. And then obviously, you guys have had me before. I'm lenient with how I grade those things. So just share that with me. Is that all right? No new homework this evening. Make sure you get those things I assigned yesterday due. Those are due tomorrow. Cool? All right.